Hi, hello, welcome to MS Academy. Please do like, share and subscribe my channel. Okay. In today's lesson, we are going to discuss. In today's video, we are going to discuss about chemical equations. Yes. So yesterday we have discussed about interpreting a balanced chemical equation. In today's topic, we are going to discuss about interpreting the balanced equation at STP. What do you mean by STP? STP is nothing but standard temperature and pressure. Yes, what happens to the equation? What are the terms we have? We have to remember in this STP. Standard, temperature and pressure. Okay, under these conditions, yes, the volume occupied by the substance. Yes, so standard temperature and pressure is nothing but the equation takes place under STP. So in order to perform that equation, we are going to do this at this reaction under standard temperature and pressure. You have to maintain the temperature of 273 kelvins. The temperature will be 273 kelvins and the pressure will be 760 nm. These are the standard temperature and pressure. Under this standard temperature of 273 kelvins, the volume occupied by the substance is 22.4 liters. It occupies 22.4 liters. So based on that, let us do a small example. Yes, what is that? Calculate the volume, mass and number of molecules of hydrogen liberated when 230 grams of sodium reacts with excess of water at STP. As I have said that STP, standard temperature and pressure. What is asking? Sodium. Sodium reacts with water. Sodium is Na. Reacts with water. It forms NaOH and H2 gas. Okay, now first we have to balance the chemical equation. After balancing the chemical equation, here we are going to substitute the values. See, 2 into sodium 23 plus 2 into hydrogen H2 2 into 1. Oxygen, the atomic mass of oxygen is 16, gives 2 into atomic mass of sodium is 23, oxygen 16, hydrogen 1 plus 2 into hydrogen 1. Yes, now these are the values we have to substitute in the above equation. Now let us read the question once again. What he is asking? Calculate the volume, mass and number of molecules. What we have to calculate? Mass, volume and number of molecules. These three terms we have to calculate for this equation which is done at STP. Yes, so here of what you have to calculate? Hydrogen. Yes, hydrogen liberated when 230 grams of sodium. So from the question it is very clear that he is comparing sodium with hydrogen. Yes, now we wrote a balanced chemical equation. We have substituted the values over there. Yes, from the balanced chemical equation it is very clear that here 46 grams of sodium, 2 into 23 is nothing but 46. 46 grams of sodium. How many grams hydrogen? H2. This is a value for hydrogen or not? Yes. When I take 46 grams of sodium, it is liberating 2 grams of hydrogen. Yes. 46 grams of sodium is liberating 2 grams of hydrogen gas. Yes. Now, what is asked in the question? 260 grams of sodium. 260 grams of sodium. So, when I take 260 grams of sodium, how much gas has been evolved? That we have to find. Now, here from the equation, it is very clear that 46 grams of sodium giving 2 grams of hydrogen. Now, in place of 46, what happens when I take 230 grams of sodium? Now, just to cross multiply, assume this term as x. Cross multiplication, what you will be getting? 230 into 2 by 46 is equal to 10 grams. Yes, 2 ones are 2, 23 ones are 23 tens are. So, when I take 230 grams of sodium, yes, when I take 230 grams of sodium, it is liberating 10 grams of hydrogen gas. Now, as we have learned that this equation has taken place at STP, standard temperature and pressure. Yes, as we have done this equation at STP. Yes, now here he is asking us to calculate volume, mass and number of molecules. Yes, so here we have calculated the mass. Now let us find volume. Yes, and it is very clear that this equation is taking place at STP. Yes, so already I have informed you that when this equation is happening at STP, the volume occupied will be 22.4 liters. Means here the gas whatever it is evolving, it is hydrogen gas. So as per this equation, so 2 grams of hydrogen, 2 grams of hydrogen is occupying 22.4 liters. What about 10 grams? Why we have to calculate for 10 grams? Why? Because here we have taken 230 grams of sodium. When we take 230 grams of sodium, we are getting 10 grams of hydrogen. Means here 2 grams gives 22.4 liters. Then if I take 10 grams, what will be the volume? So 10 into 22.4 by 2. 2 ones are 2 5s are. So we will be getting 112 liters. Now in this way we have calculated the volume. Next, coming to the number of molecules. Number of molecules are nothing but, as we all know that 2 molecules of hydrogen is occupying 1 Avogadro number. Okay, 1 Avogadro number. What is Avogadro number here? 6.02 into 10 to the power of 23. Means 2 grams of hydrogen, 2 grams of hydrogen is occupying 6.02 into 10 to the power of 23 molecules. Now, what about 10 grams of hydrogen? As we got 10 grams now, so what about 10 grams? Now cross multiplication. 10 into 6.02 into 10 to the power of 23 divided by 2. When you solve this, you will be getting 3.01 into 10 to the power of 24 molecules. Yes. So this is what he has asked here now, and we have calculated volume, mass and number of molecules. So in this way we can calculate. So in this problem, just you have to remember that this equation is taking place at STP. STP is nothing but standard temperature and pressure. Under this condition, the volume occupied will be 22.4 liters. What will be the temperature? Temperature is 273 kelvins. What will be the pressure? 760 mm. Okay, please do like, share and subscribe my channel. Thank you.